How are you guys? And today we will be talking about Ohm's law. We will first begin with our discussion with an atom. So this is an atom, and an atom has valence electrons. And when we speak of valence electrons, this is the outermost shell of an electron. Now, if you notice in this illustration, this is an atom of sodium, and sodium has one valence electron that is found in the outermost shell. And when we speak about valence electrons, these are also free electrons. So another name for the electrons found in the valence electrons or valence electron is also free electrons. Next, these electrons are ripped out, meaning they can be removed from the atom. And once you remove them from the atom, they will create electrical charges because an electrical charge is already an imbalance of charge. So when an electron is removed, it has more protons that are balanced from the original number of electrons, and so sodium becomes positive in this case. So remember that when an imbalance charge occurs, it will create an electrical charges. So sodium here can actually donate one electron to chlorine atom. So when that happens, sodium becomes electrically charged, which is positively charged. Now, there are two types of charges that we are talking here. One is positive charge, meaning to say it loses an electron. In this case, sodium loses an electron, and so it has a net charge of positive charge. So sodium becomes positively charged. And another type of charge is called negative charge. When we speak of negative charge, that means an atom gains an electron from another atom. So in the case of chlorine ion, a chlorine atom is actually accepting one more electron, maybe from a sodium atom, and with that chlorine will no longer become an atom but rather an ion. So chlorine will now have an extra one more electrons from 17 electrons to 18 electrons, making chlorine ion becomes negatively charged, so it gains an electron. So in the creation of electrical charges, these charges has electrical forces, which we are going to discuss in the next slide. And the smallest unit of electrical charges is called an elementary charge, that we are also going to talk about it next slide. So an elementary charge is actually the value or the charge value that is quantized of one proton and one electron. And what is the value equal to? The value of one electron is actually negative 1.60217662 times 10 raised to the power of negative 19 coulombs. But the charge of one proton is positive 1.60217662 times 10 to the minus 19 coulombs. So when we speak of elementary charge, these are the basic charges or the charge value for one proton and one electron. As mentioned earlier, that charges will produce an electrical force. So this force can either be a repulsive force or attractive force. And when we speak of repulsive force, if the two charges are of the same charge, in this case, it is negative charge. So if there are two negative charge or charges that are held together, they will produce a repulsive force. If these are all both positive charges, they will also produce a repulsive force. So in the case of unlike charges like negative charge and a positive charge, they will produce an attractive force. So in the electrical forces of charges, there are either a repulsive force or attractive force, and they can be calculated using the Coulomb's law. So Coulomb's law actually describes the attractive forces of our charges. So the next slide will give us the different units for our Coulomb's law formula. So the formula for the Coulomb's law is given by F sub E, which is the force of the two charges, while Ke here is actually the Coulomb's constant, and that is given by the value of 8.987 times 10 raised to the power of 9 multiplied to Newton meter square over Coulomb square. And for our Q1 and Q2, these are actually the charges and the magnitudes of our charges over r, which is the distance between the two charges, and that is raised to the power of 2. So our positive charge and the negative charge will always follow the principle of the conservation of charges. So what is the law or the principle of conservation of charges? So this simply states that charge cannot be created and you cannot also destroy charges, but they can only move from one place to another. In the case of the illustration here, so we see that the charge can only transfer from the sphere to the rod. So now we have a value of positive 2e. So there are two more electrons that are added into the rod. And so still the total number of charges actually are the same, but only that they transferred from one object to another. And it is also the same principle that is happening throughout the entire universe. Charges are created from the extraction of electrons from one atom to and it can transfer to another atom, but the number of electrons and the number of protons are always intact in the entire universe. So this is the principle of the law of conservation of charges. So the result of an imbalanced charge will produce static electricity. So static electricity is exact opposite to the electric current. So when we speak of static electricity, that means there is no flow of electrical charges. And you know, we can actually charge an object, or we can produce charges by three ways. And the first method is induction or polarization, and the second method is by means of friction. Another method is by contact. So charging by induction or polarization. So in this case, there are two spheres, and when a negatively charged rod is brought near but not in contact with the sphere, the positive charge or the positively charged are actually attracted to the negatively charged rod, while it separates the negatively charged part of the sphere into this side, while on the other sphere also that when this one is already negatively charged, all of the positive charge in the other sphere will also be attracted to the other positively, or I'm sorry, the negatively charged sphere. So leaving the two spheres actually more positively charged with the other, and the other sphere is more negatively charged. So when we will be able to separate the two spheres, this sphere letter A will already be having a net charge of positive, and the sphere B will also be having a dominant negative charge. So this is a way of charging an object by means of induction. There is no rubbing and no contact that is made. In the case of charging by friction, here is a rod and a cloth, like a silk cloth, is used to rub the rod by contact. Okay, so all of the electrons will be able to transfer into the cloth, leaving a net charge of positive into the rod. So this is a way of charging an object by means of friction. And finally, charging by contact. For example, a negatively charged rod is brought near to a sphere. It will be charged by the negatively charged rod. So since the negatively charged particles cannot actually attract, but they repel, so they will be distributed around the surface of the metal sphere, making the metal sphere negatively charged. So in this case, this is how an object is charged by means of contact. So static electricity can leak off by means of grounding. In the case of this metal sphere that is having an excess charge of negative, it can be leaked off into the ground by attaching a wire and flowing now into the ground. So leaving the sphere a neutrally charged sphere. So this is also true in the real world. For example, a metal pole, so that it will not hold excess negative charges, and one can be electrocuted or shocked when the electrical charges can sink into a person. So it is best way to put a wire connected into the ground, so that all the excess electrical charges cannot harm an individual or an organism. Now again, to describe static electricity is the opposite to an electric current, because an electric current are actually flowing of electric charges. So in the case of a wire or a metal wire, so all the electrons will flow from one atom to another inside an electrical wire. So this is an electric current. But static electricity will actually be a static, or meaning to say a stationary potential electricity that is charged into an object. Now, if we talk about electric current flows like in the one that is illustrated. So an electric current flows in a conductor. In the case of insulated wires, the copper wire inside the insulated wires is called a conductor, while the electric current will not flow in an insulator. For in the case of rubber that is wrapped around the conductor, which is the copper wire, so that is called an insulator. So they can all be found in an electrical circuit. So here is an electrical circuit where electric current can flow. So there are several pathways where electricity can flow. Now, in the case of a battery, it is the one that is pushing the electrons to flow into the wire and into the load. In the case of this illustration, the load is actually a bulb. So as the electrical current continues to flow, it will heat up the element of the bulb, and it will produce heat energy and light energy. So the bulb will glow, at the same time will produce an amount of heat. So to summarize everything up, we talk about atom, and atoms, they have valence electrons. And valence electrons here are also known as the free electrons. So valence electrons can be found in the outermost shell of an atom. So a valence electrons can actually create electrical charges. Electrical charges, or the smallest unit of an electrical charge, such as a proton and an electron, is called an elementary charge. That is the charge value of one proton and one electron. An electrical charge has force, and the force are either repulsive force if they are of the same charges, or an attractive force if they have opposite charges. And this attractive and repulsive force is described by the Coulomb's law. And Coulomb's law has a Coulomb's constant in the formula. And for electrical charges, this is either a positive charge that only happens when an atom loses an electron, and it can also be a negative charge if an atom gains an electron. So both charges, positive and negatively charged, follows the principle of the law of conservation of electrical charges. It states that charge cannot be created or destroyed, but can move from one place to another, or from one object to another. So going back to electrical charges, an electrical charges is a result of an imbalanced charge. An imbalanced charge can produce static electricity. When we speak of static electricity, there is no flow of electric charges, but electric charge can be leaked up by using grounding. So this is a way of making our materials or post and other devices safer for humans. And static electricity is actually the opposite to electric current, because electric current is a type of a flow of electrical or of electric charges. And electric current flows in a conductor. An example to this is copper. And electric current do not flow in an insulator. So both conductor and insulator is present in an electrical circuit. So an insulator, an example to this one is wood and rubber. And going back to static electricity can be produced in an object by means of induction and also by means of friction. Friction, an example to this is a glass and a cloth. When you rub them together, the cloth will actually catch up some of the electrons from the glass rod. And another way of charging an object is by means of contact, and another way is polarization. So polarization and induction can be treated as one. So this is actually the conceptual summary of our topic, which is about electrical charges, talking about static electricity, the difference between static electricity and an electric current, and the importance of the understanding of the Coulomb's law as applied to calculate the repulsive or attractive forces between an electrical charges. And so we also understand how electrical charges can be produced, and that there is actually a conservation of electrical charges in our universe. So thank you very much for watching.